Hey, what's going on? Eric Flynn and friends at Axiado Corporation. I was recently directed to Andrej Karpathy's wonderful videos on machine learning. Most of his videos talked about large language models, and I chose to follow this one because it seemed like the natural beginning. It just had to do with neural networks and backpropagation. So he shows us exactly how it works from the ground up, and I follow along in this notebook, and I'm gonna try and keep this video as brief as possible. This is my fifth take, and if I start explaining things, see, I only learned this a few days ago, but I will explain something. So I'm just trying to show you where my head is at. I'm sure whoever's listening knows more than me, so it's not like the teaching kind of explanation. It's just to show you where I'm at. Okay. So we have this, the most atomic class we have is value, and it has a lot of functions for math, and these in Python allow you to use the Python symbols like plus and multiply. These have these these dunder methods, and let me just, for example, when you add, just the brief explanation that I will do is that when you add, you may remember if you're adding some variables and then you take a derivative, the addition has almost no impact on the slope. It's just addition. And so when we're backpropagating and when we're dealing with derivatives, we have this 1.0. We're not changing, the final slope at all, basically, because we're multiplying by this 1.0. For example, and this is all in the reserved backward functions. Each reserved backward function is a generalized chain rule. So, for example, in the power function, you may remember the power rule. Here we have other minus 1. You may remember in the generalized power rule terms that look a lot like that. And in multiplication, when you have two variables and you differentiate with respect to just one of those variables, one of the variables goes to 1 and the other variable stays the same, so it's 1 times other or 1 times self, depending on which one you differentiate by. So I won't say too much more about that. It's already been 3 minutes, my goodness. This is a gift from Andrej. I just trusted it works, and it does. Alright, this helps a lot for visualizing. This is where we use those generalized chain rule functions from earlier, and we see how each of these, backpropagation sees how each of these inputs outputs or affects the output of this. And if you define this very carefully and you want it to go to 0, then you can do that, because we know exactly how each input affects it. Okay. So we have some scratch paper here for me, some fiddling with a lot of values, some experimenting. A lot of these were justifying choices that we make. I personally don't know why we need this topological graph as opposed to some other method, but of combining the nodes. But let's see. We're justifying more design choices, and there's an external library to do it. Okay, here we have a neuron, a layer of neurons, and finally the neural net as a whole. The neural net as a whole, you could define it to take in 3 inputs. It's going to have 2 hidden layers of 4 nodes and 1 output. That's just the syntax of what that looks like. Andrej explains everything here so much better than me, and I don't want to take up too much of your time. Okay, this is an example that Andrej did. Okay, new network. This is a generated data set. We're classifying whether a point is in this crescent or in this crescent, which is nice for binary classification. And let's see here. So I make the network. It's going to take in 2 inputs. 10 nodes in each layer. It just sounds like such a small number, but actually, I mean, it is a small number, really. But my poor little laptop. It's like running on 1 core. It feels like. We do some adjustments because we're using the tangent, hyperbolic tangent function. Basically, we just make each 0 and -1. That maps to hyperbolic tangent a lot better, because hyperbolic tangent outputs -1 and 1 in that range. And then we train it. This is because I stopped it on purpose because it was taking much too long, but you can see it was working. The loss, we're outputting the loss. We're printing the loss on each of these iterations. We do a forward pass here, define the loss very carefully here with mean squared error, reset the way that the gradient points, do all that derivative stuff talked about earlier, and then take a step in that direction. So as you can see, the loss nicely descends. Very nice. This, I'll be completely honest, is ChatGPT. All of this. It's just to visualize the decision boundary. And then here's another classification problem I did. We're just classifying whether something is in this circle or in this one. And this is for hyperbolic tangent. We don't need this. So here I'm making the neural network. It's going to take 2 inputs, an x and y value. 5 nodes is a lot faster than 10. It seems to square quadratically is what I learned. And we do all the same stuff that we did before. And it works. The loss is very high at first and it gets very low. Oh, here's something kind of interesting. If you do a test point like, so -8, -0.8, and 0. So here's -0.8, here's 0. It's very clearly in this outer circle. And if you print what the network returns on this input, and by the way, this input, it didn't exist in the original training data. The network returns a very small negative number, and I think what's going on here is that, well, let's look at the visualization. So this is, if it's more red, it's closer to the number 1, and if it's more blue, it's closer to the number -1. So you can see a lot of white here. So I think what's happening is that as soon as like a region of space, even though the network doesn't really think in that way, as soon as a region of space is very slightly, like correctly categorizing the dots in there, it stops. It views it as like no longer a constraint to the optimization, and then because the gradient wants to go as fast as it possibly can, because this is no longer a constraint, then the gradient, to improve itself more quickly, it doesn't bother getting all of these values up to or down to -1. It's just trying to be correct, but just barely. It's like inherently lazy in a way, which is kind of funny. And then I did it again with another set of points, and you see the same thing happening. I guess, anyway, I think the same thing is happening still. Funny how there's red both on this side and that side, and here it is again, just being like barely correct. So that's what I learned, that's where my head's at. We're already at 10 minutes, so I will stop, and thank you for watching and your patience and considering, and if there's anything I can do to be more useful, let me know. And anyway, hope you enjoyed. I'll talk to you later.